Hey guys, Gordy Roth. So I just got this package in Friday from my good friend Jay straight at Brotech, New England, and it's a Nourish Racing crank and a set of cases. They're T120 or T140 cases, doesn't really matter. They're about identical later on, and what I'm going to do with this is what's called a Superblend main bearing conversion. Here's a set of stock main bearings, and this one goes on this side, this one goes on that side. This one's a ball bearing, and this is what locates the crankshaft, i.e. when this is pressed all the way on here and this is pressed all the way in the case, the crankshaft's located laterally, and that's all well and good, but a ball bearing allows quite a bit of flex in the crankshaft, and these RHP bearings are kind of an oddball bearing anyway, and the cage in them is steel and they're very delicate, and I have seen these fail in higher horsepower applications. In a stock motor, yeah, sure, they're fine. I don't like them because of this steel cage and the way they go together. They're just not super accurate. I mean, they work, but only just, and that's how Triumph did a lot of things. I mean, you know, it just barely worked, so they just kept going with that. What I do, I've unwrapped one of these to show you what it is. This is an FAG NJ306 bearing, and you use a pair of these, and they come apart like this, and they both go with the step facing in, and that way when you put this one on here and this one on here, you can set your end play. I usually set them to, I mean, if it's a race bike that I trust someone with, I'll set them up as tight as, like, basically if the crank spins freely with the case bolts loose, then you tighten the case bolts up and it doesn't get any more resistance to turn it over, that's enough, because these cases will expand like 10 thousandths away from it when it's up at temperature. I mean, I've put them in an oven and tried that. They will expand that much, so you're not going to have no clearance. You'll have 10 thousandths oil clearance, you're fine. But for people with street machines, I usually set them up around 3 to 5, which is fine. Anyway, the machine work that requires doing is this side is not the correct size. This side, excuse me, is the correct size for this bearing. So you put this on the crank and this in the case, and then there's your location for your crank. Your alignment of your crank does not change whatsoever, and because, you know, they're bronze cage bearings, they're much more, they'll stand a lot more abuse. And sorry, I'm trying to word this all as I'm going. The machine work that requires doing is this side's the same, and then this side that goes on here is too big, as I will demonstrate. It's like 40 thousandths too big, I can't remember. This is an 1 1/8" bearing, this is 35 millimeters, I want to say, yeah. Anywho, I have tons of these old bearings that's just the inside of this that is toast, and because you can't really get them off a crank without destroying them. I mean, yeah, you can, but you have to make a really specialized tool. I mean, a lot of people just tear them up getting them off there, or they tear them up getting the motor apart. I mean, they're really easy to damage. Anyway, so I've got a bunch of these, and this will press on here at the correct size, and then what I do is I press that on there and then turn it down to the correct interference for this, and then put it on there. Then that's your crankshaft. That's easy squeezy done. Now, as for the cases, this is your timing side case. Does not require any machine work. You just put the bearing in there with the writing is on one side of the bearing. Just make sure you keep the writing on the same side of both halves of the bearing. So you're going to put the outer part of the bearing in there like that, and that case half is done. Now, with this case half, this is where the really, well, it's all critical, but this is where the really critical machine work comes in. Even though this bearing is bigger on the inside, it's smaller on the outside. So it gives you perfect room to do this, because see, that is the right size. This one is slightly bigger. I don't remember the exact dimensions off the top of my head. Anyway, you set this up on, I mean, don't even attempt this if you don't have a milling machine that isn't really tight. I mean, be honest with yourself. If your machine's a little loose, don't attempt this. You will mess up a set of cases and it'll get expensive real fast. Anywho, what I do is I take a coax indicator and set this up and just bore down to where that step is, because it's silly to not have a nice big step here that's concentric and continuous and wide enough to not move around. So what I do is I bore it to where it matches this, i.e. I just measure the other case half, and it's usually like 1/1000th and a half fit. It's not a bunch, but it doesn't need to be. Anywho, bore this back straight and to the correct size for the bearing, and then what you have to do is you start out making a shim that gets you back this thickness, because this bearing is actually, I don't know if you can see that, this bearing is actually thinner than this bearing is thinner than the old one. So you make a shim that goes in here that is your remaining thickness, and then you put it together, and that's usually too thick, usually. And then when you try and do that and put the cases together, you have to check your clearance. So then when you get the cases together, you'll set up a dial indicator and rock the crank back and forth in this direction, and like when it's like this, you like put your hand in here and move the crank up and down, and you can tell what your clearance is, and they call that end play sometimes. And as long as it's not like 20 or 30 thousandths, you're fine. If it's like 10 thousandths, that's acceptable. I don't normally prefer that much, just because it's excessive. Nortons say that it has to be that much, but I've never had a problem running it tighter than that. Another thing you can do is that these are the later metric timing side cases. On the earlier cases that are in fact inch size, this inch size bearing on both sides, but it's still ball bearing, roller bearing, or ball bearing, roller bearing. What can be done is, if you have a motor that is very old, like I got one in one time that a guy ran lots of different types of homebrew exotic fuels like mothballs and bleach, and I mean it was just amazing what this guy thought was acceptable. At any rate, it just trashed the motor, and so both main bearings were spun off of it, and in both case halves the everything just fell apart. I mean there was clearance on everything instead of interference fit. So what I was able to do is I was able to use these bearings and put a sleeve on both sides of this, and it was more complicated because you had to shim both sides, but I didn't shim the crank, but I put two NJ306 bearings on this with sleeves at the correct fit, and then I was able to bore out both the cases, and I had to shim both sides of the case. When I shimmed both sides of the case, then it was once again usable. So I did a 68 650 that way, and it made a usable motor out of it again. The benefits of doing this are just for convenience sake, it's much easier to disassemble the motor because you don't have to smack this bearing in and out of either the case or the crank every time. All it will do is this just slides apart from this, and hey presto, the case has come apart. Because it's not, the cage isn't attached to the crank and the crank's wandering around, it's a lot less likely that you will ding up one of these brass cages, which are much tougher anyway. I mean, yes, it is a bearing, you have to be careful with it, but you're doing a lot better already with using these bearings, in that this is going to be in a race bike, and to big problem we have is because we have no center bearing support, and it would be very tricky to do. I've seen it done, but not normally practiced. And by using these bearings, which they're straight, there's no angle in here for radius for ball bearings to run. The crank does not do this and flex back and forth nearly as much. So conversely, it also does not create as much friction because it's not side loading the bearings, because it can't as much. You will notice just when you do this conversion and not do anything else to the motor that it will actually rev more freely and produce more horsepower, because the crankshaft is actually staying straight like it should, so you're not being affected nearly as much by parasitic loss. This is just the overview of how this conversion works. I do this conversion for $300 and plus the cost of the bearings, and of course shipping and everything else. That may change, but as of right now, that's fair to me to do, and that's including shimming it and everything. You can ship me your lower end completely together with the old bearings on the crank and everything, just like with the rods on it and the whole 9 yards, and I will disassemble it and do the conversion and reassemble it at the correct clearance and send it back to you ready to go, if that's what you prefer. I'm flexible on that. I will show later how all of this machine work is done. Like I said, if you're not an extremely competent machinist, I mean like tool and die level machinist, or have access to an automotive machine shop that you think is capable of this, but even so, I mean, this is extremely specialized machine work, and I'm not doing this so, you know, like, hey, this is a do-it-yourself. I'm showing how I perform this. Perform this at your own risk. Like, I know if I do this, it'll be done right, but I can't guarantee anybody else to do that right. And I'm not belittling anyone else or anything. I'm just saying that this is how I perform this conversion. It's not right, wrong, or indifferent. It's how I do it, and it's how I've had it work successfully. So without further ado, I will get into how things are machined and get back with you. Thanks. Okay, so now I have this case half set up in the milling machine, and I'll try to do this one-handed. It's a little bit tough. I'm actually influencing the indicator with my hand. Anyway, I measured this bearing bore, and it's not absolutely round. It's about 1/2 thousandth out. So I've got this thing running to where it runs just about perfectly straight all the way around. There's one little spot where the indicator just like less than 1 mark wobbles around, and that is the actual ovality of the bore. So that's as close as you can get it. As long as you know your head's trammed square, and I've got it on the case halves, I got it on a parallel here, and here I've got it on the primary cover surface, and I've got a toe clamp here and a toe clamp here on my vise, and I have a penny under here and a penny here and a penny here to keep it from marring the case at all. And you don't have to monkey wrench these down. You will warp this case, so just I mean, you know, tight enough that it won't go anywhere, but not too tight that you'll warp it. That's the trick. So on with boring it. Okay, here's my scratch pass, and as you can see, it's touching all the way around. You can see where it's still like leaving all kinds of shadows and stuff. This is how badly Triumph machined stuff at times. I mean, I've gotten ones that were perfect and ones that just had all kinds of ugly marks in them. Anyway, I'm gonna keep boring on this, but as you can see, don't be alarmed if you take like less than 1/1000th like I did here, where it was just barely scratching and it does not clean up because they didn't do a very good job of boring it. So onward and upward. Another thing you run into, I've made my final bore and I dropped everything down far enough that I can get my dial bore gauge in here without smacking the spindle. So what I've done is the surface finish on this is actually a little bit coarser than, say, the original one, because it hasn't had the bearing race in there for hundreds and hundreds of hours running. So it's actually like 3 and a little bit, like 3.2 thousandths press, which is fine because if you feel the surface, sorry, I'm trying to do this one-handed. If you feel that surface, you can catch it with your fingernail just a little bit. It's pretty damn smooth, but what it'll do is when you put that bearing in there and then run it for a while, it'll actually, because this is what's called a green machine surface, freshly machined, it will settle somewhat and it'll smooth out. So and that's why when you take old bearings out of stuff that haven't completely chewed up the bore, if it's still in good condition like this one was, it'll be just perfectly smooth, because that ground outside surface of the bearing has been pressing against this under stress and heat, expanding and contracting for lots and lots of hours. So this case half is done now, and I'm happy with this press fit because of the surface finish, and it's not too rough, but it has just enough roughness to it that it will settle just that little last, less than 3/4 of a thousandth, and so just a slight bit too tight is fine. But if it's too loose, you're going to spin the bearing in the case, and I've done this enough to know that with that surface finish it should be fine. So on to the crankshaft step. So the crankshaft's in here. I normally use a 4-jaw to do this, but this is like a brand spanking new 3-jaw, and I put it in there and it's like 1/2 thousandths run out back here, which is fine because up here it's like nothing. So because you're going off of the center, so it's like 1/2 thousandths here, or less than half. It's like you can barely see the indicator needle move. Anyway, I normally do this with a 4-jaw, but for this job it's fine because the crank is actually straight enough. Some of them, the individual journals, it doesn't matter with anything else. You want this journal and this journal, and I've pressed the bearing on there so I can machine it, but you want this journal and this journal to run just about absolutely perfect with one another. And so yeah, I've taped up these so that chips don't get in there, and I'm going to start turning on this thing. And it's also a used journal, so that it may be the little bit of wibbly wobbly that I was seeing was just the wear in the journal, which is fine. So it's for all intents and purposes it's perfect. So we're going to go ahead and machine it. Okay, here it is cutting. I've got it at 126 RPM, and my feed rate is 2.8 thousandths per revolution, and I'm taking 5 thousandths depth to cut until I get one clean pass on the surface, and then I'll start taking 10 thousandths, because this stuff is so hard. The one thing you definitely don't want to do is hog too much at once before you have a clean pass, or it'll chip the insert and you're done. Also, you really don't want to get much more than about 10 thousandths depth of cut, and don't want to go crazy on the feed rate, because you don't want to make this thing flex, because I mean, see, it's unsupported in the middle. There's no way to support it. So yep, just got to keep chewing on this thing till that journal is this journal size. Final pass on here. And as you can see, the sleeve is just paper thin. I'm taking 1/1000th off of there, and that should be final size. So trick with that is I've slowed it down to 93 RPM. My feed rate's the same. I'm 1/1000th depth of cut. I changed my insert to a new insert because you will chew up an insert doing this. That's just all there is to it. So get close, and then change your insert out or flip edges or whatever, and then go from there with a like take your last 5 thousandths with a fresh insert, and you should be fine. Crankshaft. This journal now measures the same as this journal, or vice versa. This is the side I did the sleeve on. As you can see, it's just paper thin. It's like 40 thousandths thick, and that should work fine, because this was just this bearing race with the cage removed, and I just machined it down. And so if it's installed at the same press fit as this side, when you put the bearing on here, it's going to squeeze it and grab it anyway, so it's not going anywhere. So on to putting the inner races on the crankshaft. Got the oven heating up to 400 degrees. As I've shown in other videos, you put the bearing races in the oven as it's warming up so they don't heat up too fast. They heat up slowly, which is good. And then I'm doing the timing side first, then the drive side. I've got the socket and the hammer there for the drive side. If it gives me any trouble, it shouldn't, because it measures exactly the same, which means that bearing should just drop right on there. And once it's up to 400, we're going to leave it for 10 minutes and then drop that one on and then wait for it to cool off, which will take a minute or two or whatever. That big a piece of metal actually sucks the heat out of the bearing pretty damn quick. And then once that's done, we'll flip the thing over with the other one still in the oven and drop it on the other side, and in one shot it'll be done. Okay, it's been in the oven for 10 minutes. Remember, boys and girls, wear gloves. Unless you like getting burnt. I don't know, whatever floats your boat. So, as long as you drop it on there straight, it should go right on there. Yeah. And we will let that cool for a minute and do the other one. Side's turn. This should go exactly the same way if you've done your machining right. So here's hoping. A little bit tighter, but I was still able to push it on there with my fingers, which means that it's fine. And it also means it will grip that sleeve a little bit tighter, because that sleeve actually will compress slightly. So we're golden. Yep. Heard it go home. It's good. Turn the oven off. And that is crankshaft. It's very hard to record how to measure this, and actually show how to do this, but what I did was, this is an old main bearing that I took the middle out of and turned the OD of it down just enough that it will slip in there so that I can actually have a nice even surface to measure on, because that soft aluminum, with any measuring tool you use, it's very hard not to dent it, especially when it's freshly machined, so it'll give you a false reading. But with that against it, you can use an inside micrometer and you put it in here and you measure your distance. It's impossible for me to do this one-handed, but you see what you have to do. You have to measure your inner distances from right there to right there, and then you measure here to here and you subtract one bearing, or actually both bearings, and that gives you your inside distance here, which is what you need to figure out your shims. And then when I measured it all, I came up with 73 thousandths. So I had some oil field pipe laying around that it's kind of, it never gets a very decent surface finish on it, like I somehow miraculously did there. But anyway, it's fairly tough steel, but it's actually pliable. So it isn't like springy, so it'll just kind of stay put wherever you put it in compression. And 70 thousandths is what this came out to. This is also usually kind of a trial and error method, because none of these cases are flat. They just aren't. So measure all you want to, and then when you get what you think is your thickness right, I gave it 3 thousandths clearance. It'll probably end up being less than that. It may pinch even, and if it does, I just start grinding off like 3 to 5 thousandths at a time until it frees up, and then that's where your clearance needs to be set, because these will expand away from it, like I said, about 10 thousandths. And so next step is take these cases back apart, put this case in the oven, drop the shim in there, smack the bearing in on top of it, and then wait for it all to cool down. Then you have to test fit it, and if it pinches when you tighten the case bolts up, when you're test fitting it, it's too tight, and you just gotta knock everything back apart and grind this shim down. That's the only way you have of adjusting it. So here goes. Here we are again. I just love it when things do what I say they're gonna do, which is I measured for 3/1000 end float, and I've got no feelable end float, but just because of the surface area of the bearings, you may not be able to feel very, very small amounts of end float. But the way I can tell that this has more than enough is that I tighten the case bolts down here, here, and one on the bottom, which is enough. And when I tighten them all the way down, as I was tightening them down, I kept feeling the crankshaft, and it did not get any stiffer. So it will. This is usually a pretty good acid test for me, is I get it up and down like that, and I just start tipping it over, and it should. If it'll flop back and forth that easily, with no counterweights on it or anything, I mean, see, it's just free as a bird. So this is a Superblend conversion. It uses Norton main bearings and a Triumph. And in summation, what gets done is you put one bearing on this side, riding out on both halves, and then you have to machine this case half out, like 35 thousandths. I can't remember the exact number. It's from an inch and an eighth bearing to a 3/06 bearing. And then you have to shim behind the outer race of this one. And if you do all your measurements right, like I did, yay, you should end up like, I shoot for measurable clearance, in that it doesn't tighten up, which means by feeling friction, which is measure, you don't have any more than if the cases are just loose. So this is ready to go back to Jay Straight at Brittech, New England. Either give him a call or give me a call or message me or whatever if you want this done. This is on a T140 left-hand shift motor, and any Triumph twin this can be done to. Any Triumph twin, I don't care if it's an old Ironhead one, any of them I can do this to. So, oh yeah, and you have to sleeve the crank as I showed earlier. But yeah, anything you need this done to, there it is. Take care, guys.